Chuck Friedman here. Going to show you how I got stereo microphone signals inside Flash. Something that took me quite a while to do and figure out, and with the help of Adam Flater, who works on the Merapi project, we were able to bridge C# application and air and trap the microphone signal at the C# level, and via socket connection in Merapi pipe that into air and visualize it. So this was actually part of my visualizing voice presentation, and here we go. So the first step was actually to get Merapi going at the C# level, and so this is actually Visual Studio, and I had to write an app, and thankfully found a lot of source code online. I actually had never really worked with C# before, nor really analyzed sound, so I found a great example that captures the waveform in C, and then analyzes it and applies FFT, fast Fourier transform, to consolidate waveform down to left and right channel amplitude values, similar to what we get natively when we load an MP3 into Flash. So basically, if you can see this is data arrived, and this is actually an event, like an event handler method in Flash, that's being fired by the C app every time it loops through the waveform. And when it does that, it's going to apply some logic to it to, again, consolidate down so we can get those left and right channel values. Once we do that, we can send it through a Merapi message object, and this is where Adam came in to help out, and I can actually take these values, the left channel and right channel values of the microphone, and send them into an air application, which is actively connected and listening for these events. So I can run this, and it's basically a console application, something you're used to seeing in Windows at the command prompt level. So there it is right there. I'm going to go into Flex code now, which is Flash Builder. Well, I still refer to it as Flex. And this is the application. Basically, here's the hooks for Merapi that you can see right here. And so message handler, and we're listening for a stereo signal message event that's being sent by that C app. And then I'm doing a couple of things which I'll show you when I compile, but essentially what I'm doing is taking the left channel and right channel values and piping them right into the application. And the visualization of it's going to come up right here in Air application. And let me bring up the console app behind it. So what you're going to see is a couple of VU meters that I created in CS4. Pretty easy stuff, you know, like those old stereo volume unit meters that we're all used to seeing. There's a spectrum down here, and then there's a 3D visualization here with a little stick figure in the center. Again, done in CS4, so I got the 3D aspect by turning the object in CS4 up to sort of create this 3D scape of space. And essentially what's going to happen here is we're going to be able to see the left and right values coming in from the microphone. And this spectrum is actually the sort of the tug of war, the push and pull between left and right channel. What I'm doing there is I'm actually taking the right channel value and subtracting it from the left channel value, and it creates a range -50 to +50. And then based on that, I can show in the spectrum where the stronger signal is, and that's also how I move the stick figure guy around this U-shape pattern here, which is actually, again, like sort of a 3D. So one of the key things here is you need a stereo microphone, which I understand MacBooks have. My laptop has some quirky little stereo things, so what I did is I got this microphone, which is actually a H2 USB stereo microphone. It's usually used by musicians to record stuff like sets and stuff when they're on a bus, on a rock star bus, or on the road. So I'm going to plug that in here. And what this allows me to do is it actually allows me to bypass the sound card. And that way I can get the stereo signal right from here. What I like about this microphone, when I found it, which I was really lucky I found it, it actually shows the stereo values right here. So we can see those as we talk, and then it's clearly labeled left and right on the top of it, in case you didn't know which one was which. So here we are in the application, and now that that's coming through, I'm going to hit start. on my app here right at the top. And when I do that, it's going to fire a message to the C application. And now you can see the left channel and right channel data flowing right here as it's been monitored. And it's being piped right into the application. So now here I am, and you can see if I talk onto the left side of the microphone, you can see my guy is gravitating towards the left side of the spectrum. And then if I start talking into the right side of the microphone, you can see he's moving on to the right. Okay, so I'll just move into the thing here. You can see here I am talking on the left side of the microphone, and the guy is mostly on the left side. And then here I am on the right side. Hello, hello, hello. So it's really cool, I think, to just show how we're able to control something on the screen in Flash, in Air, with a device as opposed to with a keyboard or mouse like everybody's accustomed to. And that was kind of the real goal here, to just extend the interaction, in this case by voice, by microphone, which effectively is an extension of the computer's ears as the webcam is the eyes. So, you know, I think there's some really cool use cases, and now that microphone and the microphone object has been opened up in Flash Play and Air, I'm hoping that stereo is another evolution that we can explore. But for now, we'll be posting this code online, hopefully in the Merapi project FDN, and folks can download it and do some more cool things with it. But this was my stereo aspect of the visualizing voice. I'm Chuck Friedman from Rivet, as well as getmicrophone.com, and thanks for checking out stereo microphone with visualizing voice.